So question number 4 from the 2014 free response exam deals with a train and it's moving east and west. So that's on a line, okay? East and west. And west would be to the left, which would be the negative side. And east would be on the positive side, okay? Because east is on the right-hand side, okay? Train A's velocity measured in meters per minute are given by a differentiable function. And they're using subscripts to determine there's going to be another velocity, and it's going to be for another train in part D, okay? But they're using sub A to help you remember that that's the velocity for train A, okay? And then they tell you that the velocity is in meters per minute and the time is measured in minutes, and they're giving you a table. So this is a table problem, but it's also a particle moving on a line type problem, okay? So it's kind of a combination of both of them, okay? So for part A, they want to find the average acceleration of train A over the interval from 2 less than or equal to t less than or equal to 8. So that's average acceleration is the change in velocity over the change in time, okay? It's slope of a line, okay? So we want to take the train A and find the slope between 2 and 8, okay, for the velocity function, because that would give you the average acceleration, okay, not the instantaneous acceleration. Okay, so let's go ahead and go to our paper and we'll do that. Okay, so the notation for this would be from 2 to 8, right, would be v sub a of 8 minus v sub a of 2 all over 8 minus 2. And then from the table, you can look up v sub a of 8 is negative 120 minus v sub a of 2, which would be 100, divided by 8 minus 2, which is 6, okay? And then this would be negative 220 divided by 6, okay? And then that's good enough. I mean, that's a numeric answer, okay? Now, let's put units on this, okay? So if you stopped here on the AP exam, you're perfect, okay? You don't have to simplify, okay? But what are these units for velocity here, for velocity of train A? It's meters per minute, right? So this is meters per minute over minute, right? So an alternative way, and some of you guys realize this is just meters per minute squared, right? So you could also write it like this, meters per minute squared, okay? I would not use m for minutes, okay? I would probably write out meters and minutes here, okay? Because m, which one is it? Is it the meters or is it the minutes, okay? So a lot of times we'll use m for meters, okay? All right, so let's go to part B, okay? Because that's the answer for part A. So for part B, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with 5 less than t less than 8? So is there some time between 5 minutes and 8 minutes that the velocity of the train is negative 100, okay? So at 5 minutes, we were at 40 meters per second. At 8 minutes, we were at negative 120 meters per minute, okay? So negative 100 is in between here, right? So that means, and it's different. This function is differentiable, which also you can conclude, therefore, it's continuous. And because it's continuous, there's no breaks in the graph. To go from 40 to negative 120, it had to have passed negative 100 at some point, okay? So yeah, it does, okay? And so we're gonna write this up, okay? And it's a formal write-up, okay? And we'll do that next. So we would say v sub a of t is differentiable. And if a function is differentiable, then therefore it must be continuous, okay? So v sub a of t is differentiable, comma, therefore v sub a of t is continuous. Okay, so we have to establish that it's continuous to use the intermediate value theorem, because the intermediate value theorem doesn't hold if it's not continuous, because you can all of a sudden jump to another value, okay? All right, so we know, okay, that of the v sub a of 8 is the smaller of them, right? So we know v sub a of 8 is negative 120, right? And that's less than, okay, or, well, it's less than negative 100, which is less than v sub a of 5, right, which was 40. Okay, so this negative 100 is in between these, right? Okay, by the IVT, or intermediate value theorem, there must be a t. And where is this t? Okay, with 5 less than t less than 8, comma, such that v sub a of t must equal negative 100. Okay, so you have to show that's continuous, and you have to show that it's in between, that this value that we're saying is in between two of them, right? And then you know by the intermediate value theorem, there's a t in between these two t's that will give you that velocity, okay, or that number negative 100, okay? That's it for part B, okay? Let's go to part C. So part C, they tell you at time t equals 2, train A's position is 300 meters east of the origin station. So that would be on the positive side, okay? So that'd be positive 300. And the train is moving to the east, so it's moving to the right. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. And then we're going to use a trapezoidal sum because we don't have the actual function. We're going to use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. Okay, so we know we're starting at 300, and then if we add the integral, that will give us the amount of change that happened, okay? So this is kind of the fundamental theorem of calculus, manipulated a little bit, okay? All right, so let's go and do that. Okay, so I know at time t equals 2, it was a positive 300. And then we're going to add to that the integral from 2 to 12 of v sub a of t dt. And we're going to use a trapezoidal sum for this, okay? So here's, we got to start this at 2 because we know it's 300 at 2, okay? So you don't want to start this at 0, okay? So then this would be 300 plus, okay? And then we're going to use a trapezoidal sum, right, to get this integral, okay? So it's going to be 1/2, and using my table, I'm going to go from 2 to 5, right? And that'd be your delta x, or your delta t, which would be 3. That's your height of your trapezoid, okay? And then times the two bases, and now that would be 100 plus 40. Plus, and then it said we're going to use 3 subintervals, right? So that's from 2 to 5. Then we're going to go from 5 to 8. So that, because of the trapezoidal formula, it's 1/2. And then we're going to go from 5 to 8. So that would also be 3 times the sum of the two bases, and those are those two vertical functions, right? That's v of 8, 5, and v of 8, okay? So 40 plus negative 120, I'm going to write minus 120, okay? Because adding negative 120 is the same as subtracting 120. And then the third one, right, is 1/2, and then we're going to go from 8 to 12. Now that's a change, right, of 4. So that height of the trapezoid is 4 times the sum of the bases, which would be negative 120 plus negative 150. So I'm just going to write negative 120 minus 150. Okay, then we're going to clean this up. Okay, so 300 plus, and this would be 3/2 times 140 plus 3/2 times, this would be negative 80. And then plus, okay, 1/2 of 4 is 2, right? So that'd be 2 times, and this would be negative 270. And I'm going to clean this up some more, okay? Now, I would say stop here, okay? That's your answer right there. It's a numeric answer, and it's right, okay? So on the AP exam, just stop right here. Okay, but I'm going to go a little bit further, all right? So 300 plus, and you're fine. If you stop right here on my stuff, you're fine, okay? So this would be half of 140, which would be 70. So this would be 210. And then this would be half of negative 80. So that'd be negative 40 times 3 is negative 120. And then 2 times negative 270, negative 540. And see, here's a bad thing. If you make a mistake here, now you lost your answer point. Okay, so that's why I would stop like right here. Okay, because that's a numeric answer. All right. So we have 300, and this is a plus. That'd be 510. 510. That'd be negative 30. So this is negative 150. Okay, and I'm good with you writing it like that. Okay, so it would be, that would mean that the train is 150 meters. And it would be west, because it's negative, it'd be 150 meters west of origin station, okay? All right, and that's the answer to part C. You guys, I might have said that wrong. Okay, so it goes west and east, right? So this negative would be on the west side, right? So let's finish this off. At t equals 12 minutes, train A is 150 meters west of origin station. Okay, if that was a positive 150, we would have been east, okay, because east is on the positive side, west is on the negative side. And so that's why we know it's on the west side of the origin station. And let me slide that up. Sorry, guys. I'm gonna have to rip it off. Okay, hold on a second. There we go. Okay, so at t equals 12 minutes, train A is 150 meters west of origin station. Okay, and let's go to part D. So for part D, it says a second train, train B, travels north from the origin station, and at time t, the velocity of train B is given by v sub b of t is equal to that function, okay? And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals 2. Now, this is a related rates problem, really, okay? This is a derivative. They're giving us the derivative, and so we can find the derivative at any time, but this is the derivative for the train B, okay? And V sub A is the derivative for train A, and I want to know the rate of change between the two, right? Okay, so one of them, we know from part C that at t equals 2, train A is 300 meters east, and we also know at t equals 2, train B is 400 meters north, right? So this is just, it's going to be Pythagorean theorem, okay? So let's go to our paper and write this up and show the diagram that solves this, okay? All right. Okay, for D, I want to label a diagram, okay? And this is west, and this is east, and this is south, and this is north. And I know train A is the point right here, okay? And then train B is on the north, right? So that's train B. And then this distance, we want to know how this is changing, okay? That distance right there. So I'm going to call this horizontal piece X, and I'm going to call the vertical one right here Y, and this one R, okay? And you wouldn't have to call it R. You can call it anything you want, okay? So we know that, and if I take the derivative of this, okay, so I should write this, dx over dt is equal to v sub A of t, okay, and dy dt is equal to v sub b of t, okay? All right, that's how this distance is changing, and that's velocity, right? And this, how this one's changing, that's velocity of train A, okay? All right, so the relationship we have is a Pythagorean relationship, okay? Because we have a right angle right here. So we have x squared plus y squared is equal to r squared, okay? So this would be 2x times dx over dt plus 2y dy over dt is equal to 2r dr over dt, okay? So this is the distance at time t equals 2 for train A, right? Okay, so this would be 2 times 300 times, this would be v sub A at time 2, plus 2 times 400, right? Times, and this would be the velocity of train B at 2. So this would be v sub B at 2 is equal to 2 times r, right? Okay, and 2 times r. So I need to know the radius, right? At t equals 2, I know this is 300 and this is 400, right? So this is a 3, 4. If you remember, it's a 3, 4, 5 right triangle, okay? If you don't, then we'd have to go back and use this Pythagorean theorem to get r, right? So I'm going to do it like you didn't know it was a 3, 4, 5 right triangle, okay? So we have 300 squared plus 400 squared is equal to r squared, okay? So 300 squared, okay, would be, that's hard without a calculator. 90,000? Yeah, 90,000? Yeah, 90,000. And then plus, and this would be 160,000. And this would be 250,000. And then r would equal 500, okay? So this would be 2 times 500 times dr over dt. And that's actually what we're trying to find, right? Okay, so v sub A at 2, we can use the table, and that was 100. So this is 2 times 300 times 100 plus 2 times 400. And we have to find v sub B of 2, right? But we have a formula for that, right? So v sub B, I'm coming down here, v sub B of 2 is equal to negative 5 times 2 squared plus 60 times 2, and then plus 25. So that'd be negative 20 plus 120 plus 25. Okay, and so that'd be 125. And that's the velocity of train B at 2 minutes. So this would be 125 is equal to 2 times 500 times dr over dt. So now it's a matter of just solving for dr over dt, okay? Okay, so this would be 600 times 100. So that'd be 600 and then followed by 2 zeros. So that'd be 60,000 plus this would be 250, right? 400 times 250. And you know what? I should be using a calculator because you know what? Because you guys can use a calculator on this. And this would be 1,000 dr over dt. Okay, so I'm going to grab my calculator. Why struggle with it, right? Okay, so this would be 400 times 250. So that'd be 100,000. So we have, so 100,000 plus 60,000 would be 160,000 is equal to 1,000 dr over dt. Okay, let me just check my math here really quick. Yeah, that was 60,000. Okay, and then take 160,000 and divide by 1,000, and you get 160, right? I could have done that in my head. Okay, so that means at t equals 2, the distance between them is increasing 160 meters per minute, okay? All right, so the original question is this, okay? Find the rate in meters per minute at which the distance between train A and train B is changing at t equals 2, okay? So at t equals 2, the distance between train A and train B is increasing 160 meters per minute. Okay, and that's the answer to part D. Okay, so question number 5 from the 2014 free response part of the exam. Okay, they give you a table of values for F and F prime and G prime, and then they just ask you some questions. This is just some straight, I would say basic like calculus problems, okay? I would call these like a function problem. In the context, they gave you a table, so it is considered a table problem because they gave you a table of values, but they ask you a lot of like just basic calculus stuff, okay? And I think this is a really good question that they would ask you something in this format for this year's exam, because it's not like a textbook problem, okay, where you can just look it up and go, oh, this is going to be the answer, okay? All right, you can't just Google a problem like this, okay? All right, so let's go. And part A, they want you to find the x coordinate of each relative minimum of f on the interval -2 to 3, and then justify your answers, okay? So for it to be a relative minimum, it has, the f prime would have to change from being negative to positive, okay? And then the derivative there would either have to be 0 or it would have to be undefined, okay? So there's one place that happens, okay? And it's right here. So between -1 and 1, all the x values in there, the derivative is negative. And then at 1, it's 0, okay? And then from 1 to 3, it's positive, okay? So it changed from being negative to positive. That's a relative minimum when it does that, because the function is decreasing to increasing, right? And that'd be a relative minimum, okay? Like a parabola opening up, okay? I'm not saying it is a parabola though, okay? All right, so let's answer this for part A. So we would say F has a relative minimum and we could actually say it, okay? A relative minimum. No, you know what? It just said find the x coordinate, right? So F has a relative minimum at x equals 1 because F prime changes from negative to positive at x equals 1. And that's enough. We're done with part A, okay? That's the justification for why there must be a relative minimum at x equals 1, okay? Let's go to part B. So for part B, explain why there must be a value c for -1 less than c less than 1 such that f double prime of c equals 0, okay? And if you look at this, okay, we don't have values for f double prime, right? This is not the intermediate value theorem, okay? It would be if we were given f double prime, but we weren't, right? We were just given f prime. So this is the mean value theorem, okay? Because the second derivative is one derivative away, right? So this is saying we have to have a derivative at c that's equal to 0. And that's going to be true if it's differentiable and continuous, okay? Or continuous and differentiable, okay? And there's an average value that's 0, okay? An average rate of change for f prime, that's 0, okay? So let's go ahead and do that. Okay, so they're telling you that's twice differentiable function f and g, right? So that would mean f prime is differentiable on -1 less than x less than 1. Now I'm picking those because they're asking you for C between those, okay? Okay, so it's differentiable on the open, right? You could also write this as -1 comma 1 with parentheses, okay? And continuous on -1 to 1, or you could write it like this with inequalities, okay? And then we have to show that f prime of 1 minus f prime of -1 over 1 minus -1. What is that going to equal, okay? All right, so what's f prime of 1? F prime of 1 is 0, right? Minus what's f prime of -1? Well, f prime of -1 is also 0, right? So this is 0 minus 0 over 1 plus 1, which is 2, right? This is 0 over 2, which is equal to 0. So you got to do this, right? This is the average rate of change, okay, for f prime, okay? And we say it's differentiable and it's continuous and the average rate of change is 0, okay? And then by the mean value theorem, comma, you don't have to have a comma though, there must be a C, comma, and where is the C? Well, the C is between -1 and 1, right? -1 less than C less than 1, comma, such that, okay, so this is the average rate of the derivative of f prime would be f double prime. So such that f double prime of C must equal 0, okay? So one derivative away, it must exist, right? And it must be the same as this. One derivative away from the function we were finding the average rate of change for, okay? All right, so in this one right here could also be written, well, I would leave it like this just because you're saying the C is between here. I probably wouldn't write that as interval notation, okay? All right, you could say with, there must be a value C with C in, and then you write the interval. You could write it like that too. Okay, that's the answer to part B, guys. Let's go to part C. Okay, so part C is the function h is defined by h of x is equal to the natural log of f of x. Find h prime of 3 and show the computations that lead to your answer, okay? So this is, they're measuring you on the chain rule. Do you understand the chain rule, okay? So let's go ahead and write down h of x and what it's equal to, and then let's find the derivative and then put 3 in, okay? So let's go to part C on their paper. So part C, we know that h of x is equal to ln of f of x, right? Okay, one more parenthesis. Okay, so if I take the derivative of this, h prime of x, okay, so what's the derivative of the outside function, which is natural log, right? That's 1 over whatever you're taking the natural log of, right? So this would be 1 over f of x times, and then this would be f prime of x, right? Because we've got to take the derivative of the inside. So f prime of x. So basically, h prime of x is equal to f prime of x divided by f of x, okay? So what is h prime of 3? Okay, that would be f prime of 3 over f of 3. Okay, so f prime of 3, we can look on our table. I'm grabbing my paper to look for it. Okay, so f prime of 3 is 1/2. So this would be 1/2 over f of 3, and f of 3 is 7, right? So complex fraction, and if you left your answer unsimplified like this, you're right, okay? You could walk away. You can't leave your answer like this because it's not a numeric answer yet, okay? So you got to get it to the numeric answer. That's a numeric answer? Perfect, okay? I would multiply both sides by 2, or not both sides, top and bottom by 2, because this is a version of 1, all right? And we would get 1 over 14. 1 over 14. So h prime of 3 is 1/14. Okay, that's it. Done with part C. And then part D says evaluate the integral from -2 to 3 of f prime of g of x times g prime of x dx. So you should recognize this is integration by substitution. Okay, why? Because you're looking at a composition of functions right here, right? And you're multiplying, right? You're integrating a product, And what you have right here is the derivative of this inside function. That's always a classic case for integration by substitution, okay? So let's go ahead and do that one. Okay, so they're asking to find this, right? And what we need to do is we need to do u substitution. So we're gonna let u equal g of x, and then du would equal g prime of x dx. So these two right here make my du, right? So this is equivalent to the integral, okay? And I'm just gonna hold off doing these limits because I have to find them in terms of u, right? So this would be f prime of u, okay, du, and then these become basically x values, right? Okay, or we need to switch them to u values. Sorry. So this would be g of -2, and this would be g of 3. Okay, so this would be equivalent to g of -2. So we got to look on the table. What is g of -2? And g of -2 is -1. So we're going to integrate from -1 to g of 3, and g of 3 is 1. And then this is going to be f prime of u du. Okay, so the antiderivative of f prime is f, right? So this is going to be f of u evaluated from -1 to 1. So that's just f of 1 minus f of -1. Okay, what's f of 1? F of 1 is 2 minus f of -1, and f of -1 is 8. And 2 minus 8 is -6. So this integral is equivalent to -6. Okay, that's all there is to it, guys. That's part D, and we're done for today. All right. Hopefully, I really hope, and I usually get the feedback better than what we're doing this year, right? Because we're not seeing each other. Okay, but hopefully you're starting to catch on. It's like, oh, I get this. This is just like what we've been doing, right? A lot of them are starting to look familiar. By going through and doing a lot of multiple choice, a lot of free response, you start to get better at it, and you start to recognize, oh, they're asking me for this, and you get faster, okay, and all that. All right, so that's it for today. Just hang in there, be tough, okay, keep striving for getting a passing score on that AP exam, all right, so you can get some college credit, all right, because it's all worth it, all right, it's all worth it. All right, you guys take care. I'll see you tomorrow.